In this video, we'll discuss about Young's theorem. This theorem is according to the mathematician W.H. Young, but उनका जो प्रूफ था उस प्रूफ को फॉलो करना डिफ़िकल्ट है. Basically, this theorem states out the equality of mixed partials. So, what is Young's theorem? Young's theorem. Suppose we have a set which is a subset of R2 and A comma B is a point of the set. Then this theorem states that, Young's theorem states that if fx and fy both differentiable at the point A comma B, then if xy a comma b is fyx a comma b. So this is a condition for equality of the mixed partials. So पहले इसका proof देख लेते हैं. Since fx and fy both are differentiable, therefore fx, fy both are continuous at the point A comma B. Okay, so there exists a neighborhood of A comma B such that fx and fy both exists on that neighborhood in AB. Also, if xx, if xy, if yx and fyy all exist. कहाँ पे exist हो रहा है? At the point A comma B. अब एक रियल नंबर h चूज कर रहे हैं R से, शो दैट ये जो पॉइंट हो रहा है A प्लस h कॉमा B प्लस h, A कॉमा B प्लस h, A प्लस h कॉमा B, A comma B, all these 4 points belongs to NAB. So we are choosing H in such a way that all these points belongs to the neighborhood of AB. So basically, for imagining the things, suppose this is the direction of A, this is the direction of B, then if this point is A comma B, then this is A plus H comma B, and this is A comma B plus H, this is A plus H comma B plus H. Basically NAB is a neighborhood of A comma B such that all 4 points are belonging to this neighborhood. So we are choosing H in such a way. Now we are defining a function. If H comma H. How? F of A plus H comma b plus h minus f of a plus h comma b minus f of a comma b plus h plus f of a comma b. So this is basically a function. What we are doing, we are taking this point, at this point the functional value minus this point's functional value, and we are taking the functional value difference of this, and taking this combination we are defining the capital F function. Now take this as equation number 1. Now if we define phi y is equal to f of a plus h comma y minus f of a comma y for all y belongs to b to b plus h, then what we can tell, f of h comma h is equal to phi of b plus h minus phi of b, right? Suppose this is equation number 2. Because we defined phi y in such a way, if we put b plus h in place of y minus if we put b in place of y, then we are getting fhh function. Okay. Now since fy exists on NAB as phi is differentiable function of y, therefore phi is differentiable function of y on that interval, this interval b to b plus h, correct? Then we can apply the Lagrange's MVT, mean value theorem, such that there exists theta belongs to 0 to 1, such that phi of b plus h minus phi b will be basically h into phi dashed b plus theta h, right? This is basically by applying Lagrange's MVT. So now phi of b plus h minus phi of b by equation 2, or phi of b plus h minus phi b is equal to f of h comma h. Now we are writing right hand side. What is at right hand side? So this is basically fy a plus h comma b plus theta h minus f of y a comma b plus theta h, right? Because phi is a function of y, and in this equation we are just putting phi dash b plus theta h. We are replacing y here by b plus theta h, correct? Okay, we'll just adjust f of a comma b here, and we will put plus f of a comma b here. Why we are doing this? It will be more clear if we'll rewrite this. सो फर्स्ट पार्ट को ब्रैकेट में ले रहे हैं a plus h and theta is 0 to 1. Now since fy is differentiable by the assumptions of the theorem, fy is differentiable, then fy a plus h comma b plus theta h minus, sorry, this was fy, this was fy, minus fy a comma b. इसको हम क्या लिख सकते हैं? बाय द डेफिनेशन ऑफ डिफरेंशिएशन ऑफ fy, एक बार तो xy a comma b ये कांस्टेंट के साथ h आएगा, और दूसरा बार fyy a comma b इस कांस्टेंट के साथ थीटा h आएगा, प्लस एप्सिलॉन 1 h इंटू एप्सिलॉन प्लस एप्सिलॉन 2 इंटू थीटा h, वेयर एप्सिलॉन 1 एंड एप्सिलॉन 2 ये जो दो फंक्शन है, दिस आर फंक्शंस ऑफ h, वेयर एप्सिलॉन I h आर फंक्शंस ऑफ h, and epsilon 1 and epsilon 2 goes to 0 as h tends to 0. So this is pretty clear because we have just applied the differentiation formula for fy. So for the first bracket we will replace these terms, and now let's see the second term. So in the second term what we have? Fy a comma b plus theta h minus fy a comma b. So this will go as, फर्स्ट x का डेरिवेटिव वाला कांस्टेंट आएगा a comma b into the change in x coordinate, that is 0. सेकेंड में क्या आएगा? fyy a comma b into y कोऑर्डिनेट में जो चेंज है दैट इज थीटा h आएगा, एप्सिलॉन 3 इंटू 0 एंड एप्सिलॉन 4 इंटू थीटा h, वेयर एप्सिलॉन 4 is a function of h and goes to 0 as h tends to 0, right? Because fy is differentiable, same reason applying the formula. Now if we'll put these terms to this function here, what we'll get? F of h comma h, h जैसा ब्रैकेट में था रहेगा, उसके साथ फर्स्ट ब्रैकेट के लिए एफ एक्स वाई ए कोमा बी इंटू एच, एफ वाई वाई ए कोमा बी इंटू थीटा एच प्लस एप्सिलॉन 1 एच प्लस एप्सिलॉन 2 थीटा एच, और माइनस एफ वाई वाई ए कोमा बी थीटा एच माइनस एप्सिलॉन 4 इंटू थीटा एच, ये आएगा. अब ये दोनों टर्म कैंसिल हो जाता है, तो बेसिकली क्या मिला? h इंटू एफ एक्स वाई ए कोमा बी इंटू एच प्लस एप्सिलॉन 1 इंटू एच plus epsilon 2 minus epsilon 4 into theta h, correct? Therefore f h by h square क्या आएगा? f x y a comma b plus epsilon 1 plus epsilon 2 minus epsilon 4 into theta, correct? Now if we take the limit h tends to 0 for both sides, then what will happen? Epsilon 1 tends to 0 as h tends to 0, epsilon 2 minus epsilon 4 both are tending to 0, so we are getting fxy a comma b, correct? We define it relation star. नाउ एकदम इनिशियली हम लोग जो फंक्शन डिफाइन किया था, सिमिलरली और एक फंक्शन अगर हम लोग डिफाइन करते और 5y वाला जो फंक्शन डिफाइन किया था, सिमिलरली और एक फंक्शन को हम लोग डिफाइन करेंगे. कैसे करेंगे? सपोज psi x is equal to f of x comma b plus h minus f of x comma b for all x belongs to a comma a plus h. then हमारा जो पहला फंक्शन था एफ एच एच, ये क्या हो जाएगा? पहले लिख लेते हैं एफ एच एच फंक्शन क्या था. सो एफ एच एच किस में कन्वर्ट हो जाएगा? साई ऑफ ए प्लस एच माइनस साई ऑफ ए, करेक्ट? सिमिलर आर्गूमेंट के साथ अगर हम लोग चलेंगे तो सिमिलरली हम लोगों को मिल जाएगा लिमिट एच टेंस टू 0 एफ एच एच बाई ए स्क्वायर एफ ऑफ वाई एक्स ए कॉमा बी. दिस इज रिलेशन डबल स्टार से. So from star and double star, what we can write? F of x comma y x y a comma b is equal to f of y x a comma b. So this is basically the proof of Young's theorem.